Myself Sanjeev Kesar Tripathi, expert of physics from MKD Education. Today we will start second chapter, that is Scalar and Vector. So we will switch over to new chapter, Scalar and Vector. Now we will start new chapter, Scalar and Vector, that is chapter 2. Again I will be explain now the physical quantity. The same physical quantity again is divided into two parts. One is scalar quantity, another is vector quantity. And this important of scalar and vector play very important role in physics. So then we will switch over what is scalar quantity, what is vector quantity. The outcomes of this subject after the outset of this class, student will able to know the vector quantity and scalar quantity. Physical quantity, which is divided into two parts, that already I have explained to you or stated. Then the outcomes of the subject is student able to know the two types of physical quantity, which is vector and scalar. And vector quantity is associated with the different law of addition, subtraction, multiplication and division. Because scalar quantity can be added algebraically, but vector quantity cannot added algebraically. It will be follow certain rule and regulations as is given here. Parallelogram law of vector additions. First we are going to be define what is vector quantity, what is scalar quantity. Scalar quantity is a physical quantity which does not possess direction, only have magnitude. So therefore here it stated physical quantity which has only magnitude but have no specific direction, that is scalar quantity. For example, scalar quantity, mass is a scalar quantity, density is a scalar quantity, pressure is a scalar quantity. These are generally, there are so many scalar quantity which can operate algebraically, just like 3 kg plus 5 kg. Simply you can say it is 8 kg, which is added algebraically. Just like 2 centimeter length is a scalar and 5 centimeter, then it is equal to 7 centimeter, which can be operated generally in algebraically method. But vector quantity cannot operate algebraically. What is vector quantity? A physical quantity which possesses magnitude as well as direction is called vector quantity. For examples, force is a vector quantity. We write that is force is equal to suppose 5 Newton. Force is equal to 5 Newton. 5 is the magnitude of the force and Newton is the unit, as already explained in the chapter 1. That means this is a vector quantity which possesses both magnitude as well as direction. In physics, the direction means there are 4 directions. As per our convenient, you know there are 4 directions. We will consider that is east, west, north, south, which is mutually perpendicular to each other. These directions which I have to explain are associated with the physical quantity is called a vector quantity. Next, we will going to be different types of vector. But before that, I will be explaining you notation of vector quantity. A vector quantity can be noted by putting a arrow mark on its head. Suppose A is a vector, it can be written in this manner. This is called a vector. Similarly, force is a vector. We can put a arrow mark on its head and which is called a vector quantity. But scalar quantity have no arrow mark on its head. That is called representation of vector quantity. Next we will switch over to term and definition or variation of vector quantity. First is equal vectors. 2 vectors are said to be equal if both have same magnitude and same directions. Suppose this is a vector quantity A vector, that is A vector, and this is the B vector, and both have same directions and same magnitude. Then we will say that A vector and B vector are equal vector. That will represent A vector is equal to B vector. That is called equal vector. Next is negative vector. If 2 vectors are said to be negative if they have opposite direction. They have opposite direction is called negative to one another. Suppose A vector is in this direction, one vector, A vector. The negative vector of A will be must be direction in this way, that is minus A vector. This which are opposite to original vector. Suppose this is plus A vector, so opposite direction indicate that is negative vector. That is called negative vector. Next is co-initial vector. If the number of vector originating from a same point or originating from same place, then it is called co-initial or concurrent vector. For example, suppose the number of vectors will be originating from a point, this vector A vector, B vector and C vector. These vectors are said to be co-initial vector because they are originating from one point. That is called co-initial vector. That is called co-initial vector. Next, we will switch over to parallel vector. Two vectors are said to be parallel if they have same direction and angle between them is 0 degree. A vector, suppose this is A vector and suppose the B vector. This vector, A vector, is said to be parallel with B vector if in between them angle is 0 degree. If the angle is 0 degree, then we will say that it is parallel vector. So anti-parallel vector, next is written is anti-parallel vector. Anti-parallel vector is a vector whose angle is 180 degree, that is opposite to each other. Suppose this is A vector and suppose another vector is B vector which is opposite to each other. So therefore in this case both angle between them is 180 degree. That is called anti-parallel vector. That is called anti-parallel vector. Next I am going to unit vector. Unit vector is a vector, another is unit vector, that is whose magnitude is equal to 1. Unit vector can be represented by putting a cap on its head. That is called unit vector. A is a unit vector whose magnitude is equal to 1 are called unit vector. Next is non-vector. Non-vector is a vector whose magnitude is 0. That is called non-vector. These are the various types of vector. Next, already I have explained two various types of vector and their definition. Now we will switch over to operation of vector. Vector cannot be operated algebraically as already I have stated you. First operations, that is addition and subtraction. If I will explain addition, then subtraction is nothing else, it is the opposite to additions. First law we have to study, that is called triangle law of vector addition. Triangle law of vector addition. According to this law, if two vectors P and Q are taken along the two sides of a triangle in same order in magnitude and direction, then their resultant vector is represented by the third side of the triangle taken in opposite order. That I am going to explain. Suppose this is a vector, this is a vector and this vector suppose a B vector. If I will consider this vector as the two sides of a triangle taken in a same order, that means suppose I will represent this is A vector, this is B vector. This is A vector I am representing, this is B vector. That means same order means I am moving in the same direction. I am moving in the same direction. That is same order. A vector and B vector. As per the statement, if two vectors are taken the two sides of a triangle taken in same order, whether you understood the meaning of order or not. That order means I am going in a same. This arrow mark indicating the same way. Then the third side or closing side of the triangle taken in opposite order. Please mark this arrow mark. I am going initially from A to B in this direction. The third side I am putting in the opposite direction. That is called opposite order. So therefore this is O, this is A, this is B. So OB represent the resultant of these two vector A and B. Therefore resultant R is equal to A vector plus B vector. It is geometrical representations. OB geometrically represent the sum of these two vector represent this line OB. That is called resultant of the two vector. Next, We will switch over to another law of vector operations, that is parallelogram law of vector additions. As per the statement of the law stated that if two vectors P and Q are represented by the two adjacent sides of a parallelogram in magnitude and direction, then the resultant is given by the diagonal of the parallelogram passing through the point of intersection of the two sides. That is the law which is stated. Again I am repeating, if two vectors are represented by the two adjacent sides of a parallelogram, then the diagonal will represent the resultant of the two vectors originating from the intersection of the two sides. That I am going to be explain you. Suppose there are two vectors, I will be represent the two adjacent sides. Suppose this is A vector, this is B vector. Suppose I will represent these two vectors, the two adjacent sides of a parallelogram taken in same order. So you look this diagram very carefully. This is A vector, this is B vector, which is represent the two adjacent sides of the parallelograms. Then I will complete this other two sides of the parallelograms. Other sides of the parallelograms, that is, suppose this is O, this is A, this is B, this is C. This A vector and B vector, I am here representing the two sides of the parallelogram. Or as per your statement, you can say this is P or Q, same as that PQ. So therefore these diagonals which represent the resultant of the two vectors, that is R is equal to A plus B vector, taken in opposite order. This is a geometrical representation. Now we will switch over to mathematical representation or derivation of this law. Produce OA, produce OA, produce OA and draw a perpendicular from B on produce OA, which meet at D, which meet at D. Suppose this angle is alpha and this angle is considered as a theta. BAD consider as theta and BOA angle considered as alpha. So therefore here there are two right angle triangles, OBD, because this is the perpendicular, this is a perpendicular. So OBD is a right angle triangle, another right angle triangle BAD. So therefore first there are two unknown, the value of AD and value of BD. First I will evaluate the value of AD by using trigonometry concept. In triangle ADB, in triangle ABD, sin theta is equal to BD by AB. BD by sin theta is equal to BD by AB. This is B vector. This implies sin theta is equal to, that is BD by B vector. Or this implies BD is equal to B sin theta. BD is equal to B sin theta. So therefore this B value of BD is equal to B sin theta. Again I have to find cos theta. Cos theta is equal to AD by AB. Then AB value is B, already you know, therefore AD is equal to, that is B cos theta. AD is equal to B cos theta. Therefore now we are going to find the value of OD. Therefore OD is equal to OA plus AD plus AD. Value of OA is equal to A vector. This is A vector plus, and value of AD is B cos theta. That is B cos theta. This is B cos theta. Similarly, value of BD is known to you. That is B sin theta. Now we will consider this right angle triangle OBD. In triangle OBD. Then in triangle right angle triangle OBD, we have to apply Pythagoras theorem. In Pythagoras theorem, hypotenuse OB square is equal to OD square plus BD square. We got my point. This is I am applying the Pythagoras theorems. In this theorem, the diagonal square is equal to sum of the square of the other two sides. Therefore, OB square is equal to OD square plus BD square. Now we are going to put the value of OD, that is, and BD. So therefore, OB square, value of OD is equal to this much, that is A plus B cos theta whole square plus B sin theta square. B sin theta square. Then you will be evaluate this. By evaluating this, you will be obtained OB square is equal to, that is A square plus B square plus 2AB cos theta. 2AB cos theta. Therefore, OB, which is equal to our resultant R, is equal to square root of A square plus B square plus 2AB cos theta. This is the magnitude of the resultant quantity in this expression. That is, the resultant OB is equal to R, which is resultant, is equal to A square plus B square plus 2AB cos theta. In this way, you can find the resultant of the magnitude. Then we will switch over to how we find the direction. In case of our directions, we will switch over, we will consider the same right angle triangle, that is O, that is same right angle triangle ODB. In ODB right angle triangle, tan alpha, in triangle again we will consider in triangle ODB, tan alpha is equal to BD by OD. The value of BD already I have calculated, and value of BD already you know. Value of BD is equal to B sin theta. Value of OD already calculate, A plus B cos theta. Therefore, alpha is equal to tan inverse of B sin theta by A plus B cos theta. In this way, you can find the direction of the resultant. So this is the derivation, mathematical or analytical expression or derivation of the resultant of the two vectors according to parallelogram law of vector additions. Then key point, the quantity have both magnitude and direction are called vector quantity. The vector are added analytically and graphically to find the resultant. The triangle law parallelogram gives the resultant. To get the magnitude of the resultant, what I have explained you, resultant R is equal to A square plus B square plus 2AB cos theta. Same way it is written, P square plus Q square plus 2PQ cos theta. Next we will discuss some important question. Then first, what do you mean by resultant? As already I have stated you, the resultant means additions or subtraction of two vector quantity by applying either triangle law or parallelogram law of vector. State the triangle law of vector additions, as already I have explained you, stated you. Next, state parallelogram law of vector additions. The law I have already stated or refer the study material. What is the formula for magnitude of the resultant of the two vectors by parallelogram law, which already I have derived, and again I am showing you this formula, that is resultant is equal to A square plus B square plus 2AB cos theta and that square root. This is all about the vector additions.